Good afternoon, everyone, and thank you for joining us today. My name is Lisa Stanis. I am the Director of Business Development and Marketing here at Sharper Shape. And today I am joined by our Director of Product, James Conlon, to talk about digital twins and talk about how you move all of that data that you have into a digital twin to help you make some good business decisions today. And so, real quick, as people are starting to get logged in and joining us, I just wanted to go over housekeeping. There is a chat feature in the lower right-hand corner of the screen, so feel free to type in a question or chat. There also should be a Q&A too if you wanted to send us just a question. We can take those. We will look at all of those questions and chats at the end once James has a chance to go through his presentation, and we'll answer any questions that you have. So with that, I will check in with James and see if he is ready to take over.
Yes, I'm ready. Thank you very much, Lisa.
Awesome. Thanks.
Nice, and thank you everybody for your time and attention today. Let me share a screen. All right, so my name is James Conlon. As Lisa said, I'm the Director of Product Management and Customer Success here at Sharper Shape. We can see the screen now. Is that right? Can you confirm that, Lisa, or chat?
Yes.
Excellent.
Yep, I can see it. You're good to go.
And today we're going to talk about digital twins, how to build them, how we can hopefully help our customers, and if you're a utility, if you're a first-party utility yourself, how to capitalize on actually building a utility living digital twin and move that from O&M, hopefully, to a capital expense portfolio. So first of all, we'll take a look at who are we. So we are Sharper Shape. We are a company who was founded in Finland from researchers from the Finnish Geospatial Research Institute. And since then, we have really blossomed into a software as a service tech company, as well as a collections company, a processing vendor, and really a partner to some of the US's largest investor-owned utilities. We have a really huge tech stack. So we have hardware packages for manned aviation collection operations. So that's remote sensing operations where you collect LiDAR, you collect RGB or hyperspectral imagery, you collect other kinds of information, other kinds of data from the air. We have field servers, on-prem solutions to capturing that data raw and placing it into a cloud solution where we offer the rest of our suite of tools. So on data processing, we have experience with resolving GNSS data with these high volume data collections, actually QAing this data to engineering standards. And then where we get to the real meat and potatoes of our offering, we're talking about really high quality feature extraction from LiDAR and RGB images for utility uses. So we've done this for a number of years. Our deliverables often include things like vegetation management databases or data products that can allow people to improve their efficiency, their effectiveness with their trimming cycles, engineering grade exports. So that might be high quality classified LiDAR. It might be vector models that are used as an input to improve a GIS system of record, or as for some of our customers, engineering customers, as inputs for PLS CAD modeling, right? So that's kind of at the end of our work with these data. The other offering that we have that we'll talk about a lot is a platform named CORE, which stands for Cloud Optimized Remote Evaluation. In this platform, data that flows in from our or third-party collections is processed, analyzed, QA'd, and then delivered right there in the portal. So we have thousands of users using CORE. We'll actually move to the next slide. Thousands of users who use CORE in over 1 million annual sessions. Folks log in, they consume these images, they consume this 3D data and the analysis therein. We've collected about 7.5 petabytes, more than that, I think, and this is actually what lives in our AWS right now. Enough wire miles to wrap around the Earth several times. tens of millions of images, hundreds of millions of trees, and as I said, over 3,000 users actually active in the platform. So remote sensing, we believe, and the concept of reality capture, we believe is one of the most important pillars to solving some of the problems that utilities have today. Utilities built this energy grid sometimes over 100 years ago, and it's built in the, amidst the chaos of supply chains, workforce training issues, and just dealing with the harsh realities that are out there. So you're trying to design a new build for a new feeder. When you actually get on site, you can't build it where you want it to go. So your system of records that contain the engineering designs are now and have always been out of sync with the actual as-built that's out there. Remote sensing and LiDAR feature extraction especially assist with this by conflating and improving those systems of record based on what is actually there. It's actually sometimes shocking to us still that, that isn't the way things have always worked. So why is that important now? Well, obviously wind and weather events are becoming more problematic, certainly for some of our customers in the US. Those supply chain problems that we've seen since COVID still haven't settled down and may never. The average age of the skilled workforce required to actually maintain the grid it gets higher every year. I think the average age of a line worker now is 45 or maybe 46, and it increases by several months every year. The increased amount of load and demand on these networks is skyrocketing thanks to some of these data centers and some of these huge generation facilities that are needed to meet these demands. Similarly, the grid's getting more complicated. Distributed energy resources at the ends of these grids or at various parts of these grids are making them more complicated. And essentially, utilities are being asked to do more, and they have to do it with less people and less money. So if we have a solution, if we can build digital twins and use the analysis from the digital twin to solve or mitigate some or all of these problems, or partially mitigate these problems, why aren't we doing it already? Why don't our customers simply just build digital twins, and why haven't they done this themselves? Well, it's really expensive. Historically, it is thousands and thousands of dollars per mile to do this kind of work, to scan networks, to field teams of folks that can collect this data, to process the data, QA it to a high enough standard and deliver it. And it takes a lot of time when it comes to the actual processing. We see sometimes of up to 6 months delay from capture to deliverable. And of course, if you're basing your vegetation management on 6-month-old data, although things don't change incredibly in 6 months, in certain places they do. Whether it's something that is now growing into a fall in risk, it's grown half a foot, or whether it someone has cut something, a property owner's cut something, and that whole tree is gone. 6 months can mean you're spending some time going to incorrect sites and not getting any work done. And lastly, utilities are resistant to change. We speak with utilities all the time. We go to these same conferences that you folks do. And sometimes a utility will be bold and say, look, we've done this thing on foot or on horseback for 100 years. We don't need new technology, right? It's hard to change that one. We do have some really key champions amidst our customers who are really powerful in their abilities to enact change. So socializing these kinds of technologies is really valuable there. But other things, and also the capital expense offering is a really nice way to change that. But other things that we'll talk about here are leaps forward in automation. That's how this stuff changes, right? It shouldn't take 6 months to get your data through a pipeline like this. We've now been doing it. We've been doing it for about 7 years. Our competitors maybe haven't been doing it that long, but they've started further ahead because technology's come a long way. So these leaps forward in automation allow us to quicken the time to delivery, lower the cost for delivery. So utilities can either get more done with the same budget, or they can actually afford to do their first collect. We can also find more opportunities to extract value, and that's what we really aim to do with Core. As an opportunity for collaboration as well, a central repository, a central portal that we, of course, evangelize for this kind of data is a perfect way to say, hey, we know that vegetation management needs a collect this year, but maybe does an engineering department as well? Can we collaborate in terms of the budget and in terms of where this stuff is delivered? Maybe even piecemeal the schedule out when you have such a robust platform. This stuff becomes possible, and it makes the actual offering of making a digital twin, exporting files from that, to be a really viable way to get data and get useful insights to these different business units. Next, as we've seen, some of our customers are being successful in actually capitalizing the expense. So we'll go into that later in the webinar, but essentially there are criterion from which a digital asset can somehow transform, becoming a transformative property of your system. And that is actually, grounds for one of the grounds for being able to capitalize an expense rather than use and make a rate case rather than use your O&M budget. So next up, utilities should expect more from their data. We see people still using legacy file systems, right? Your deliverable that you're paying millions of dollars for will be 10 files inside of my SharePoint or my Azure or Google Cloud S3 platform. They will be named for the date they were collected. They will be named even though they were collected across multiple days. They will be named for the modality. They will be named for all of this. I'm an engineer. I want to work on this data. I have to look through a legacy file system, nested folders, download the exact point cloud tiles to upload to PLS CAD. Every vendor might have different data structures, different kinds of formats. One department may not ask for the same kind of geodatabase. So there's no homogeny in the way that utilities themselves even ask for these collects. And then, again, carrying on with this, what we offer as a digital twin is that we replace things like a legacy file and folder structure with user interfaces and user experiences for consuming data in the ways that you would expect, right? We're all probably social media consumers. We all know what the kind of experience that you expect when you're browsing, a video streaming platform like YouTube, or a social media platform, a giant database of different people like Facebook or whatever people use these days. So these UIs and UXs are pretty standard now. People know how to work with them. You know how to use a search bar. You know how, because you've clicked a poll in a system or a person, you can see all the pictures of them. You can read everything about them. Why not give this to these workers? And that's exactly the kinds of things we're doing. Instead of raw file downloads, right, you can, for the most part, do a lot of this work by using a cloud optimized format to just observe the data remotely. There's no reason to download 2 LAZ files, load them in something just to make a measurement between 2 points, if that's the kind of thing you're doing. And inconsistent data structure types. So for us, we have our own data model that's proprietary, but essentially pretty open and flexible. It works like this. Your GIS asset or a utilities GIS asset lives in our database in a special place, and anything that contains it, any point cloud that we know sees that pole, can be loaded to the surface of your interface. Any image that sees that structure is loaded because we analyze where the sensor was facing when the image was captured. And all of this enables users who aren't really even technical to simply just search a pole number, search a street address, consume any data that pertains to that feature that they're looking for. Attribute tables, things like that are there as well. All of the properties from the models, the attachment heights of different connections and things like that. You don't have to worry about any of this anymore, right? Loading ArcGIS, which is a phenomenal program, of course. But you don't have to do that if you're a construction worker who's looking at the access road in. Similarly, siloed information. You have a project from this year that's captured for transmission. Later next year, another organization within your business collects a different kind of data with a different kind of output, and there's no homogeny there. So we see really great success in some of our customers who actually create program management offices from the concept of performing and managing remote sensing collection events. Large utilities where they can say, actually, we shop around, we find budgets from this group, this group, this group. We're going to pull it all together. We know the data products that they use. They even might filter it through their own QA folks before they disseminate it and socialize it through the organization. Next up is how to build a digital twin. And so I would talk, if this was longer than 30 minutes, I would talk to you for a few hours on this. But what we're going to look at is how to build it really quickly, and then the value streams, right? How we try to socialize what you actually get out of this stuff. So for us, a digital twin is made from remote sensing data, scans of what's actually there, right? We use our proprietary heloscope, or we can easily accept third-party or even utility data if they're collecting it themselves, which is another trend we see these days. We take this, it has to meet some standards, right? We do want an absolutely accurate digital twin. We don't necessarily want a relatively accurate digital twin unless you're doing certain use cases. So we take this data in, we analyze it, we have, again, this spatial analysis where any kind of data with spatial properties, it covers somewhere on Earth, can be consumed, thought about by our analytic engines, and then we make an object that says, yes, an image was here. Here is a 3D volumetric shape showing where this image was captured. Showing the contents of what this image captured. And that means we can make these really robust experiences like the one I mentioned earlier. You click a pole or a guy wire, and now I can see I get a dynamic library of every image that sees my guy wire. I get all of the point clouds that had returns from this guy wire. Next, on the AI side, of course, what technology webinar would be complete without using the acronym AI? In this case, our AI models are a state-of-the-art US utility-based point cloud classifier where we can find 27 classes that pertain specifically to the kinds of deliverables we see. So we find poles, we find cross arms, transformers, buildings, vegetation. We find a huge amount of classes. I'm not going to list them all, right down to the actual substation fences and substation equipment, things like that. So this model, like I say, is state of the art. Many of these F1 scores are greater than 0.95 for the larger classes. And these are, macro averaged F1 scores. So that is to say that the accuracy is scaled to the prevalence of that item in a point cloud. Next, we have AI detections and classification. So while we're building a digital twin, images that hit the platform run through our inference pipeline. That pipeline looks for a huge number of components to detect. And then for the components we detect, we classify them into different things. Like a transformer is classified into, healthy or defective, or a cross arm might be classified into rotten, cracked, or has holes or something like that. There are sometimes cavities in cross arms. And these are just the sort of raw analysis results that go into the data products that we're building. Next, for heuristic analysis, we have automatic vector models. So when we find a pole, In the point cloud, our modeler attempts to wrap a cylindrical shape and fit a cylindrical shape to those points and strings a skeleton through that. And that skeletal model we actually use for the pole lean assessment, pole height, things like that. All the attachment points are projected against this pole model. Catenary wires are also found in the point cloud, as well as for vegetation. Our original founders were first to market, I believe, with a tree segmentation algorithm that also finds canopies as well as tree tops. And from there, once you have wires, trees, and poles, our vegetation encroachment pipeline allows you to just measure the distance between them and say, okay, if a tree is ever within 10 feet, let's create a database object right there. Now, the digital twin is made of different parts. So, of course, we talked a little bit about the UX UI, but as a decision engine, right, risk modeling at scale allows you to roll all of these millions of database points back up to that GIS system of record. So, as we'll see when we get to another slide, if you're thinking about tree trimming, which are your most affected circuits? Which feeders, which spans are most affected? And we'll get into some images of that shortly. From data products, we have engineering grade exports. These might be inputs for PLS CAD, or it might just be your engineers can consume this and happily not visit a site. And then for operationalization, we have the central repository where anyone can remotely access. Every worker you have can just remotely access the latest scan of your network. So this digital twin, the value streams are enabling vegetation management folks to really do more with their budget. So vegetation pre-inspection is an $800 per mile job. It is being a qualified forester or arborist, walking lines, usually with some form to fill in. Most of this can be automated using a digital twin. Inspection also. So remote desktop review, if you go to this digital twin, you click on a pole, you can fill in a form right there and say, I noticed this. You can put 20 poles in a work order and say, I'm going to look through every image and I'm going to figure out, do I need to go on site? Do we need to fix something right there? Again, this is all about waste elimination, preventing truck rolls, preventing site visits, having accurate location data for assets, which is not a typical thing for any utility we've seen. And then for engineering, right, it's your input for PLS CAD, as I was saying. And now with recent regulatory rules, things like GO95, where you have hundreds of different things that you may need to measure and detect and control about your network, becomes far easier to do at scale. If you need to flag every pole that's leaning a certain amount of degrees, or if you need to flag any wire that's too close to the ground, too close to a road even, these tasks are no longer sending a person out with a laser designator. It's now, we flew it with a helicopter and the results are in. So from there, vegetation management, the outputs of these value streams are updating legacy systems of record, improving the resilience of the network, and then actually having this digital twin, this three-way relationship, this cycle. You refine your digital twin. There are new things in your system of record, of course. You're building new lines. Your actual as-built network is more resilient to all of the wear and tear, and your teams are more effective at actually working on them. Now we've got some slides showing some of this stuff in action. So this data-driven digital twin allows, and this is these are screenshots from inside of our platform, are enabling people to remotely patrol their networks. Here you can see all of the vector models. You can see point clouds colorized by the orthomosaic files. All of this data is fused together. to make a really rich environment, right? Substation fences, road to wire, wire to ground, tree to wire measurements are just all there to be consumed. Of course, things like dashboards, like for engineering standards tasks. So here we sort our poles by which pole is leaning the most. We sort our circuits by which circuit has the most quantity of wires that are too close to the ground that are lower than 15 feet. And then from the actual UX perspective, so we've been doing this a long time, and we have some really talented designers and developers who have created a real one-stop shop, where you can schedule entire inspection programs within this platform. You can mark up your findings. You can use the AI components that have been detected to help you refine and train new models, as well as have dashboards and project tracking tools to let you guys actually say, oh, here are the milestones on my project. June, I start the project. By July, I should have every image there. Every poll should be marked as collected. And by the end of August, my dashboard should say that I have all of my polls inspected. And then, of course, the typical kinds of API integrations where you're sending the inspection results to SAP or to something like that is back in that tune of refining the system of record. That's just a really satisfying to see kind of image that we get to see all the time, where our tree detection and segmentation works along with satellite data. So, every green point is the location of a tree. If there is a red point, it's a tree that can fall to the power line. And it's always super satisfying to see it line up really well with satellite data. But what we found is that unfortunately people don't like to have millions and millions of points shown to them as they work as a utility worker or a veg management person. So what we do instead is boil that up to that circuit level and the segment level. And now we can say, here are the most affected circuits by these points, these problematic trees. Two more slides before Q&A. This is a quick one. So a digital twin use at scale looks like this. Data is captured. It actually doesn't matter if it's a giant collection event or you just have people with iPads in the field gathering data to update the digital twin. Data captures from the field is analyzed in some way. It might be you take a picture, we just make sure we understand where it is on Earth, or it's a really complicated analysis like the vector modeling we talked about. Then we deploy it, right? Once that data is QA'd, once it makes sense, it's deployed into the digital twin. You might be putting in vegetation management remarks like we trimmed this line. You might just be putting in new images. I was an inspector. Here's my iPad image for the day of this poll. I've fixed the problems. You enroll folks into that environment. So now everyone in your utility, simply searches for a poll, goes there, as I mentioned, consumes whatever data they need, fills in some forms, and then hopefully your team leads can see reduced truck rolls. You can see people using this data across multiple projects. We see a lot of customers right now who are standing up data scientist teams. They're all they've got their own problems. They're trying to train models. The digital twin as a actual input layer for these models enables the data scientists to never worry about where they're getting data from. We see a lot of folks, they're still using those legacy file systems. No, it's like use our API, scrape all the trees in this place from that endpoint, run your analytic job, and then post the results back. So although some of those things we don't typically do because we don't have a super public facing API yet, which will be coming at the end of the year, hopefully. This is where we see this stuff heading, right? We're trying to empower all workers from non-technical to highly technical. And then the most important thing is that these systems of record, the actual, business centers and power centers of a utility are updated based on this reality capture, this living system where all collection events flow into it. Lastly, capitalization. So, and we are not the experts on this. Our customers are. And what we understand is that there are a set of criterion that must be fulfilled for a collection, building a digital twin, and performing this kind of work to be capitalized on. So future economic benefit, right? Operations that exceed, that last for longer than a year, intangible asset creation or enhancements to an existing system, something that becomes part of how the utility operates, right? This is a test that they call being used and useful. And even part of a project, right? If your data collection operations build the digital twin, there may be paths to capitalization. And then not routine or repetitive. So if it's not part of your regular cycle of we do 20% of our inspections every year. Yeah, we also have some regulations, things like FERCA. I've got some notes on this, A121000 that permits capitalization and implementation for configuration of cloud software, which is a big one for our customers because that's exactly the kinds of things that we see. And then multi-year subscription software as a capital rights of use asset. So even if subscription fees are expensed, setup integration and modeling costs can be capitalized that can apply directly to the digital twin build process. All right, I was asked to leave 15 minutes for questions, and I almost did exactly that.
Great job, James. Thanks for that. And, something James said as he was presenting, we could talk about digital twins for hours. So if anyone is interested in continuing this conversation, we'd love to have those one-on-one discussions because the digital twin is different for every project, every company. And so it'd be really a good opportunity to speak one-on-one to talk more specifics about your project or your company. So with that, we will start the questions. And James, I'll have you help me out. We've got some chats coming in. I've got some questions coming in. The first one, have you had any customers use this digital twin platform for buried cables, cross-bonding boxes, switch gear, or switching yards?
Yeah, we've seen, not so much on the switch gear and the, let me see, what was the other buried cable? Not for the bonding boxes, but for where to underground, right? Like those folks that are working on those kinds of undergrounding projects, we've seen them using digital twins for stuff like that. So it's go to the UX, filling in a form, circling, grabbing a portfolio of media to take into their other workflows or however they're actually doing that. But really, it's such a general purpose concept that we see the same kind of thing for people flagging, bodies of water. Like we see environmental workers who are like, yeah, well, we have to find bodies of water with endangered species and things like that. So, and the undergrounding seems to be similar to that, like finding the right place, finding good candidates for that. Yeah.
Good. Next question from Rick, interested in more information on the proprietary data model. Do we support CIM for electric network structure connectivity attributes?
That's a really good question. I was muted there and I couldn't find the button. Yes and no. Typically, we're not asked for connectivity in the topology of wire connections. However, it is something that we can do. But no, our data model is different than that. From the 3D perspective, it is very, very similar. We just have a slightly different domain. We don't have all of the items that they have because from LiDAR point clouds, you can't typically extract all of those kinds of things. So for us, it's like wires of type rather than, the actual stranding and things like that. So not exactly, not the same thing.
And is the data capture tied into capitalization?
We found that the initial data capture can be, and then from there's a bit of a gray area. And I think I will say, and I think, correct me if I'm wrong, but what we'd like to be able to do, if someone has really specific questions where we can maybe help put them in touch with someone, if you're a utility and you're looking to speak to another utility finance department, we can see if we can set that up.
Yeah, yeah, that makes sense. We can't obviously divulge the information of who our customers are and who's doing it, but yeah, if we get permission from them, we can try to connect you with them. Okay, are you creating models in other design at formal besides PLS CAD?
Um, so for us, models are, so we really are strictly at that M1 level where we'll tell you the shape and the places of things and also the type of things they are. For things like PLS CAD, like SpiderCalc, OCalc Pro, and things like that, like Nira, they're talking about the actual components a lot of time, the manufacturers and things like that. So we would consider the results of building a digital twin as the input for those processes. And in the case that you can reuse what we've already done, you should be able to make them a lot quicker. So that's half of the answer to that question, I think. For us, we don't do modeling in any platform other than the platform we built. We usually will subcontract it out or whatever. The other answer to that question is that for engineers that are using those platforms to perform modeling for, estimators or designers, they'll take the results of our analysis. We'll have a UI or a UX that shows you this pole has two cross arms. This one is 30 feet from the ground. They're just using that to update their OCalc models or SpiderCalc models, things like that.
Nice. And Jack, I do see your chat in here. I do have your contact information, so I will reach out to you and send you an email and we can set up that call. Okay, and we've got a few, that's the chat. We've got a few questions that came in as well. How long does it take to produce a digital twin?
So it really depends on the things that you ask for, right? Because some of these things go from fully automated exports with a small QA step, right, where you just make sure that the types of the wires aren't the wrong type or something like that, in some special cases where a neutral looks like a span guy wire or something, all the way to like customers ask for specific attachment points for equipment that have to be found completely manually, right? And one upside of that is that, a central repository gives a way for a low-cost labor workforce, or a more affordable labor workforce can access this data without it leaving the US. But really, we're seeing a time of about 30 to 90 days at the 90 days being the most extreme. And like I say, we've seen historically like 6 months is up to a year. You sometimes don't see LiDAR data coming back. So
Great.
one
And so,
to 3 months. Sorry.
no. Go ahead and finish. I was going to say there's another question, kind of a follow up to that. So once the digital twin is created, can it be integrated with any other systems within the organization?
Yeah, we typically find we're sort of well, if you make a modern platform, then it's probably built on the same kind of principles that it should be, where you'll have a REST API. It will be able to integrate with whatever you like. We find a lot of the time that the thing that stops us is that, if you have an SAP install, you probably have an SAP specialist or champion that works for your organization who has to edit your configuration, so that the slow part won't be on the digital twin side. It'll be on the legacy software. But yeah, it can. Yeah, sure.
Okay. On the call today, we have people from different industries. So we have electric utilities on, we have drone service providers on. And when we talk about the digital twin, a lot of times we talk about working directly with the electric utility, but we do know that we have a lot of drone service providers out there collecting data for those utilities. So can you talk a little bit about how maybe a drone service provider can use this platform when working with an electric utility?
Yeah, so I was actually a Part 107 pilot for a number of years before working at Sharper Shape. And for me, if I had to perform a drone project, if a utility told me, James, go and collect 1,000 poles worth of images, if they told me any more than 10, I would buy a core license and make myself a flight order and use the iPad. And I just know I could get it done faster and cheaper. So we have a whole set of workflows. I don't know if I think I showed a slide. It doesn't really show anything about the iPad stuff, but let me see. Do I have a slide here? No. But essentially, I mean, what you're talking about is, I know that the digital twin kind of falls to me. It's similar to the AI thing. It's like conceptually, it's a very broad window. But if you throw a KML in core, if you throw a shapefile or a geodatabase in core, you now have a way to dynamically associate things you capture with the things in the system. So if your utility gives you, you've been awarded a drone project, you get a scope of work, and you need to field some teams there, throw that work in core. Every day, have your teams upload images, fill out any forms. You probably need to fill in a risk assessment, give them a 15-day look ahead for your flight ops. All of that stuff's already built in. We worked closely with some really large utilities to really flesh out that side of the platform about 4 years ago now.
Yeah, great. Okay, well, I am not seeing any other questions come in, and we are almost at our time anyways. So thank you all for joining us. We appreciate your attendance and your questions, and we do have a couple follow-ups to make with you. And keep an eye out for our next webinar. Have a great day, everyone. Bye.
Thanks, everyone. Bye-bye.